Hello grade 6. Today's lesson is titled Area and Perimeter. We are going to be working in our Jump Math 6.2 book on pages 100 and 101. Our learning target for today is I can find the area and perimeter of rectangles. Before we begin, we are going to define perimeter and area. A gentleman has created a YouTube channel and he explains both of these concepts much better than I can. So we are going to watch a portion of his videos. And these videos are from Math Antics. I will post the full videos if you would like to watch more. So here we go.
In this lesson, we're going to learn about an important concept in geometry called perimeter. Perimeter is just a fancy math term that means the distance or length around a shape. But what exactly does the distance around a shape mean? Well, distance or length is a one-dimensional quantity that we can measure with units like centimeters, inches, or miles. That means that perimeter is also a one-dimensional quantity that we can measure with units of length. For example, the perimeter of a shape wouldn't be just 10, but it could be 10 centimeters. Or instead of being just 25, it could be 25 miles. The units are really important when you're talking about perimeter. Okay, but what exactly do we mean by around a shape? It seems like there would be a lot of different ways to go around a shape. Some of them would be short, and some of them would be very long. Well, perimeter means the absolute shortest distance possible around a shape. That would be the distance you'd get if you trace the path exactly around the border or edge of a shape. A good way to see what perimeter is to imagine that you could walk right along the edge of a shape, like this five-sided polygon. Imagine starting at one of the polygon's vertices and then walking along each side until you got all the way back to the point that you started from. The total distance you traveled would be the perimeter of that shape. In this case, if the length of each side of the polygon was 10 meters, the total length you would travel along all 5 sides would add up to 50 meters. Another good way to see what perimeter is to imagine that you could take a shape, like this square, and break it at one of its corners. Then you could unfold the shape until it formed a straight line. The length of that line is the perimeter of the shape. Doing this helps you understand why perimeter is a one-dimensional quantity, even though it applies to two-dimensional shapes like this square. It's one-dimensional because it's the distance of the lines that go around the two-dimensional shape. Okay, so now that you know what perimeter is, how do we measure or calculate it for different geometric shapes? Well, that depends on the shapes. Finding the perimeter of shapes that have curves, like circles or hearts or things like that, can be tricky. In fact, we'll wait and talk about the perimeter of a circle in another video. In this video, we're just going to focus on how to find the perimeter of polygons. Since polygons are made from only straight sides, it's easy to find their perimeter. If you know the length of each side, all you have to do is add them up, and the total length you end up with is the perimeter of the polygon. And you can see that the shorter sides are each 5 meters long, and the longer sides are each 10 meters long. So, let's add them all up. We can add up the sides in any order we want to, as long as we don't forget any sides or accidentally count any of them twice. And I think I'll add up the two short sides first. 5 plus 5 equals 10. Next, I'll add up the two longer sides. 10 plus 10 equals 20. And now, if I add up those two answers, I'll get the total for all 4 sides. 10 plus 20 equals 30. So, the perimeter of this rectangle is 30 meters. You thought I was going to forget my units, didn't you? Not this time. Here's another good example.
Alright, now let's take a look at Math Antics area video.
Welcome to Math Antics. In our last geometry video, we learned that all two-dimensional shapes have a one-dimensional quantity called perimeter, which is basically the outline of the shape. In this video, we're going to learn that these shapes also have a two-dimensional quantity called area. To help you understand what area is, let's start by imagining a line that's 1 centimeter long. Now, let's imagine moving that line in a perpendicular direction, a distance of 1 centimeter. But while we move it, it leaves a trail, almost like the end of a paintbrush. By moving the one-dimensional line that way, we formed a two-dimensional shape. And all of the space or surface that we covered along the way is the area of that shape, which, as you can see here, is just a square. Okay, but how much area does this square have? Well, our original line was 1 centimeter long, and we moved it a distance of 1 centimeter, so we could say that this shape is a square centimeter. Just like a centimeter is a basic unit for measuring length, a square centimeter is a basic unit for measuring area. But there's other units for area too. For example, instead of a centimeter, what if our line had been a meter long? And what if we had moved it 1 meter? The area we'd have gotten would be 1 square meter. Or what if our line was a mile long and we moved it a mile? We'd have a square mile of area. So just like with perimeter, the units of measurement are very important when we're talking about area. Alright, so that gives you a good idea of what area is. But how do we calculate area mathematically? Well, there's some special math formulas or equations that we can use to find the area of different shapes. In this video, we're going to learn the formula for squares and rectangles and the formula for triangles. To find the area of any square or rectangle, all we have to do is multiply its two side dimensions together. They're usually called the length and the width. So the formula looks like this. Area equals length times width. But it's often written with just the first letters of each word as abbreviations. A for area, L for length, and W for width. So let's see if that formula works for our original square centimeter. If we multiply the length, 1 centimeter, times the width, 1 centimeter, what do we get? Well, 1 times 1 is just 1. But what about centimeter times centimeter? Centimeter times centimeter just gives us square centimeters, which we can write like this using a 2 as an exponent. We read this as centimeters squared, and it's just a shorter way of writing centimeter times centimeter. So whenever you see units like centimeters squared, or inches squared, or meters squared, or miles squared, you know it's a measurement of the two-dimensional quantity area. Okay, our formula, area equals length times width, worked for our square. Now let's see if it works for a rectangle. Here's a rectangle that's 4 centimeters wide and 2 centimeters long, or tall. First, we plug the length and width into our formula, 2 centimeters and 4 centimeters. Then we just multiply. 2 times 4 equals 8, and centimeter times centimeter is centimeter squared. So according to our formula, the area of this rectangle is 8 centimeters squared. And we can see that's correct if we bring back our original square centimeter. If we make copies of it, you can see that exactly 8 of those square centimeters would be the same area as this rectangle. Great. Let's try our formula on one more rectangle.
All right, I think you did a great job explaining perimeter and perimeter and area. If you would like to watch those full videos, make sure to check the Power Learning page. All right, we are going to start on page 100 in your Jump Math book, and we will start with 1A together. It says, measure the length and the width of each rectangle in centimeters. Find the perimeter and area of each rectangle. Write the answers in the table. For perimeter, for shape A, which has been done for us, they recognize that 2 of the sides were 3 centimeters long, and 2 of the longer sides were both 5 centimeters long. So they have multiplied by 2 and then added them together. Remember, our order of operations says that we will do anything in brackets first. Alternatively, they could have just added up each side. So we know that this side is also 5 and this side is 3. So 3 plus 3 plus 5 plus 5. So we know 5 plus 5 is 10. 3 plus 3 is 6. So our total would be 16. This is another way of writing that same equation. We know our area is the length times the width. 3 centimeters times 5 centimeters is 15 centimeters squared. In order to complete the remaining rectangles, you will need to find a ruler. Please continue to measure in centimeters. Let's try B together. When I measured with my ruler, I found that the width of this rectangle was 2 centimeters. It is 3 centimeters tall. Therefore, I know that the two long sides are both 3 centimeters and the width is 2 centimeters. So my perimeter is 2 plus 2 plus 3 plus 3. Remember, perimeter is just the outline around the shape. 2 plus 2 is 4, 3 plus 3 is 6, and 4 plus 6 is 10 centimeters. Don't forget your units. The area is the length times the width. So 3 centimeters times 2 centimeters equals 6 centimeters squared. I would like you to complete the remainder of this chart all the way to rectangle F. When you have finished part A, please do the remainder of page 100. I will read each question for you, but we won't solve these questions together. B says, shape E has a greater perimeter than shape A. Does it also have a greater area? C, name two rectangles that have the same perimeter and different areas. D, write the shapes in order from greatest to least perimeter. E, write the shapes in order from greatest to least area. F, are the orders in part D and E the same? G, Alice thinks that a rectangle with larger area always has a larger perimeter. Is she correct? Explain. H, Tristan thinks that a rectangle with larger perimeter always has a larger area. Is he correct? Explain. Now let's turn to page 101. Question 2 says, write an equation for the area of a rectangle with a length of 4 units and width 3 units. Well, we know that the formula for area is length times width. So the length is 4 and the width is 3. Part B, write another pair of numbers that multiply to 12. Continue on and finish C and D on your own. Question 3 says, fill in the first 2 columns of the table to find all rectangles with perimeter 12 units and sides with lengths that are whole numbers. So, if we had a length of 1 unit, 1, 2, 3, 4, 5 wide, we know that the 2 sides of 5 plus 5 will equal 10, and the shorter sides 1 each. 1 plus 1 is 12. 1 plus 1 is 2. The long sides added up to 10. So 10 plus 2 is 12. That is one shape that has a perimeter of 12. Can we make another shape with a width of 2? So we know that the 2 shorter sides will give us a total of 4. That leaves us with 8. If we split that in 2, we know that the length must be 4. So 2 plus 2 is 4, plus 4 more is 8, and another 4 is 12. So if the length is 2, the width is 4. All right, can we keep going to make another rectangle with a perimeter of 12? What about if we have a width of 3? Well, 3 plus 3 is 6. So we've used up half of the perimeter. What if we do 3 by 3? 3 plus 3 is 6, 9, and 12. Next, calculate the area of each. So we can see that the first one has 5 square centimeters. 1 times 5 is 5. 2 times 4 is 8, and 3 times 3 is 9. And we can see that confirmed with our drawings. We have done part A and part B together. Now try part C on your own. Question 4 says, each square on the grid is 1 centimeter long. A. Draw a square with perimeter 12 centimeters. You had a hint in our previous question. What is its area? Part B. Draw a square with an area 16 centimeters squared. What is its perimeter? Part C. Can you draw 2 different squares with perimeter of 12 centimeters? Explain. D. Can you draw 2 different squares with an area of 16 centimeters squared? Explain. Finally, question 5. Do you need to find the area or the perimeter to answer the question? Let's do part A together. How much paper is needed to cover a bulletin board? All right, imagine I have a large bulletin board in my classroom. Sometimes we put a border around the outside of the bulletin board. A border would measure the perimeter, but if we are wondering how much paper will be required to cover the whole board, we are referring to area. Please try B, C, and D on your own. And that is all for today.